Okay, we are on to U5A2 electrochemical cells. So we are in electrochemistry, and this is one of the major uses of electrochemical cells. So basically what we're doing here is we're forming a battery. So if you, what this will help you to do is understand some of the theory between batteries. So first of all, what you will need to do is print off this sheet right here, which is standard reduction potentials for different metals. Don't forget when you do this, it goes on to the back. So let's say that we wanted to form a battery out of copper and zinc. So the first thing I can do is find copper on the list. And what I'll write down is the formula. One second, please. Okay. Equals, just got to find one thing here, 0.34 volts. So the next thing I want to do is figure out another metal that we're going to make our battery out of. So I'm going to go to zinc now because this is the example that they use. So I'm going to write down the formula for zinc. And this is the reduction of zinc. And now I'm going to get my voltage potential here, negative 0.76 volts. Okay, so the first thing you have to do once you write down your first the next thing you have to do once you write down your first formulas is figure out what's going to be reduced and what's going to be oxidized. So whatever's reduced, the electrons are going to go to it, and we're going to call it the cathode. Whatever's oxidized, the electrons are going to come from there, and we're going to call it the anode, because electricity is the flow of electrons. Whatever is higher up on this chart, so all you do is you look at the chart and you start going down. Copper comes before zinc, so copper is reduced. So we leave this formula the way it is. Copper is having electrons added to it. That's reduction. That means that the zinc is oxidized. So what we have to do is show the formula for zinc being oxidized. Well, all you do to show oxidation is the electrons are leaving the zinc is you flip the formula. If you flip the formula, you flip the potential. Now all you do is you add up. So since we've changed everything, now all we do is we add up the 0.34 and the 0.76 and we get the voltage for our battery. 1.1 volts. The other way you can do it without all this manipulation is find the one that's higher up and write it down, 0.34, and subtract the one that is lower down. And that way you don't have to show all this formulation here. You get the exact same answer of 1.1 volts. What does this battery look like? The thing that's oxidized is usually written on the left-hand side. The thing that's reduced is usually written on the other side. And basically what we do is we put these in a salt solution, zinc sulfate, copper sulfate. The electrons will flow in this direction. So the electrons flow from the zinc to the copper. Zinc comes off of this, so this anode is going to break down. This is called the anode. And on the cathode, we're going to get a buildup. The electrons, the ions are going to go onto the copper right here. Now, this structure here is called a salt bridge. Because we've got all these ions breaking apart and reforming, what we have to do is balance them. So this is just a salt bridge to balance out our salt solution in each of these beakers. If we don't have a salt bridge, this will not continue to go. Okay, this is part 1. Part 2 is going to be very short, and it's coming right up.